till now, we've been looking at using our nature table to help us find maximum and minimum turning points. For a closed interval, you could find that your maximum turning point isn't necessarily the maximum point on your graph. So if you imagine you have a graph that looks like, say, this. Okay, now your maximum point in this graph is clearly here. However, depending on where you cut this graph off, so say I cut this graph down here, we could find that this end point is actually slightly higher than your maximum point. If I was to say cut my graph off over here as well, we would then know that this point down here is going to be your minimum point. By cutting it off here, this point here isn't necessarily a maximum or a minimum. So closed intervals could present you with new maximums and minimums. Now there are slightly less steps to be able to do this, but we are starting off the same as we have been in the last few lessons. So first thing that we need to do is find your x value of our stationary points, and to do that we need to find our derived function. So f of x is 3x squared minus 6x. Remember that at your stationary points, so at SPs, f dashed x is going to be equal to 0. If I set that equal to 0, 3x squared minus 6x equals 0, and remember you're then factorising. So first thing to do is look for a common factor. We can take out a common factor of 3x, then left with x minus 2 in your bracket. So either x is equal to 0, x is equal to 2. So we now need to find the corresponding y values for this. So when x is equal to 0, y is equal to, remember at this point you're back to your original function, and remember f of x and y are the same thing. So we're going to have 0 cubed minus 3 times 0 squared plus 10. My 0 cubed leaves me with 0, 0 squared times by 3 leaves me with 0, so we've just got 10. So this would give us the coordinates 0, 10. When x is equal to 2, y is going to give us 2 cubed minus 3 times 2 squared plus 10. So 2 cubed is 8, 2 squared is 4, times it by 3 gives us 12. Add on 10, so that's going to give us 6. So that gives us the coordinates of 2, 6. So if we had 0, 10 as one of our points and 2, 6 as one of our points, we would then go on to find out the nature of them. So are they maximum turning points, minimum, rising points of inflections, falling points of inflection? However, we're not interested in the nature at this point. We're just interested in which one gives us a maximum value and which one gives us a minimum value. However, as the graph is cut off between -3 and 3, they also need to be considered as your maximum and minimum values. So if x is equal to -3, where the graph is cut off, y is going to be equal to -3 cubed minus 3 times -3 squared plus 10. Working through that, so -3 cubed gives us -27, -3 squared gives us 9, times it by 3 gives us -27, and then we're adding on 10. So that's going to get us to -44. When we consider what happens when x is equal to 3, y would be equal to 3 cubed minus 3 times 3 squared plus 10. So 27 minus 27 plus 10, so that's going to give us 10. So when x is equal to -3, we got the points -3, -44. When x was equal to 3, we got the point 3, 10. So if you think about what they would look like on your graph, your maximums and minimums are all about your y coordinates, because your y coordinates are the points that go up and down. So our highest y coordinate is 10, but that 10 happens twice. So actually we have two maximum points. So our maximum turning point and our end point are both as high as each other, and your lowest point is this -44. So your end point is actually further down on our graph than potentially your minimum turning point. So that means that this could essentially be any nature. It could be any of them. So minimum value or min value is negative 44 when x equals negative 3. Our max value is 10, and that happens when x is equal to 0 and when x is equal to 10.